Hi, I'm Matt O'Malley of Geologic, and we're here at the prototype construction site where we'll be talking to you today about these windows that we've just unloaded from a sea shipping container that came all the way from Germany. It sounds like a long way to go to get windows, but we've done it for very specific reasons, and I'm going to tell you a little bit about that. The first reason that we are using the German windows is their energy performance is extremely good. It's a triple glazed window. As you can see in the glazing, it looks like any other window that you've ever seen, but there's 3 panes of glass here with argon gas in between each layer. The benefit of that is excellent thermal performance. The other thing that's wonderful about these windows is that, as you can see on the back side here, is a lovely pine wood frame. The wood has a natural insulating property, which is also beneficial for the window, because believe it or not, in this window that we're looking at right here, the majority of the heat loss isn't through the glass, but is actually conducted through the frames of the window. There's a lot of different frame materials and types out there, and what's very standard practice in Germany is to use a wood window with an aluminum clad exterior. The benefit of that is you get the thermal performance of the wood as well as the visual beauty of the wood, and then you get the durability and long-lasting finish of the aluminum on the exterior face of the window. So from a material standpoint, it's beneficial. The second advantage of the wood is that we have a clear finish, which is very durable and lovely to look at. It's easy to maintain, to clean up. And the benefit of it being on the interior is that it doesn't have to wear with the harsh weathering conditions that we see in Maine. Again, the aluminum cladding on the exterior is a very durable material and is well suited for the exterior environment. Now, if we were to make the entire window out of aluminum, we would see a disadvantage because aluminum is a tremendous conductor of energy as well as electricity. And if it were to be the entire frame of the window, then a lot of energy would be conducted through, much more than the wood does behind. Another material option for the frame of a window is vinyl. Vinyl has a questionable environmental record, but another problem of vinyl is it too conducts significant thermal energy, much like the aluminum, not quite as much as aluminum, but certainly more than the wood. And the other thing about vinyl is that it expands and contracts with heat, which over the lifespan of a window will compromise its durability because there's so much movement of the frame in relationship to the glass. So we find that when we're looking for the best window we can put into the prototype, that the German technology of an aluminum-clad exterior and a wood interior is certainly, for thermal energy and maintenance, the best choice that we've found. There are other reasons why we've chosen to use the German windows as well, and that has to do with the insulated glass itself that the Europeans are using. We've spent a long time looking at heat model energy loss of the windows and the building shell. We've spent a lot of time calculating different glass types and frames types to look at how do we optimize the heat loss and solar gain of our building, what's the best glass to use, and believe it or not, there's a lot of difference when it comes to not only the glass but the special low-E coatings that they put on the glass to make them more energy insulating. That for us is a very important factor because when we're looking at all the window and glass options out there, we're very specific in how we look at the values of the glass in regards to their insulating value and how much sun energy they let in. Because believe it or not, the majority of the windows sold in the US have low-E coatings on them which actually reflect more solar energy off the window than they allow into the building. So in other words, in real numbers, they'll allow only 30% of the sun's energy in through the glass into the building. The rest of that is reflected out to the out of doors. Now, if you're thinking of a house in Maine, you have a lovely south facade, you put a lot of windows in that, and you think by installing windows to allow the solar gain in that you'll actually be getting all the heat that the sun's producing into your interior living spaces. If you were to install a standard window with a standard low-E coating, the sad fact is the majority of that heat energy would be reflected out. And then when you factor in the thermal performance of the window, you would actually see that the window on the south facade loses more heat energy than it actually gains from the sun. In our case, the European glazing that we've chosen has better numbers in terms of their performance. In this case, the glass will accept 60% of the solar energy in, which is a relatively high number, while having an extremely high insulating value as well. So when our south-facing glass is hit by the sun, the majority of the sunlight comes in, and because our windows are insulated so well, the glass is insulated so well, the majority of the heat will then remain in. So we do in fact have a solar collector at that point, instead of, as in most cases, a solar reflector. Another reason that we've chosen to use the German windows is the fact that they have so many options for operability, and the windows function very well in terms of the day-to-day use of the window, opening and closing, but also when the window's closed, you can seal it very tightly, which will reduce the air infiltration of the window. That's very important as well, because air that leaks in and around windows contributes significantly to the heat loss of a building. So here is what you call a tilt-turn window. It's a great little unit. This one happens to be going in the bedrooms. Here's the handle. We haven't installed the window yet, so I'm going to show you by inserting the handle. Usually the handle is fixed and installed. But the great thing about this window is it has two ways that you can open it. By inserting the handle like this, you can tilt the handle to the side, unlocking the window, and in doing so, open it up to let a lot of air in. And also, when you open it up that way, you can also remove the screen and clean both sides of the glass. Then, when you close it for ventilation purposes, you can tilt the handle so it's facing up, and then just use it as a hopper window, which, for example, when you're not around and a rainstorm were to come up or bad weather, because this opens to the inside, you won't get any moisture or rain or whatever in, but all the while being able to ventilate the house. So this is a really great option, because a lot of times we're using windows just for just a little ventilation. And by doing so, this allows that ventilation to happen without having the potential of getting a lot of rain and moisture in the building. So a really great function. When you close it then, you turn the handle all the way down and then lock it. What's great about that is there's a locking mechanism which goes all the way around the window unit. So when you actually rotate the handle in the locked position, all those metal pieces come together and seal the window sash to the frame. And in doing so, you completely cut out the infiltration in and around the window. Again, making it a very high energy performing window, not only from the glass, but also because no air leaks in. So as you can see, we have a building ready to receive the windows. We have all the units on site, and now our job today is to put them in. On the south facade, we have a large opening, which, as I mentioned before, is useful for the solar gain and being able to collect all the sun's energy inside the building. In this case, we've looked very carefully at the size of these windows versus the size of the building, and we've looked at, again, at the heat loss and the climate, and we've found a proportion which really benefits the energy performance of the building. The windows here are certainly large, but they won't result in overheating because the size is related to the heat loss of the building. So we've been very careful to engineer this building, particularly the south facade, so we don't have overheating in the summertime, and it's very comfortable in the winter time. I think a lot of people assume that when you have a lot of glass on the south facade that the result will be that the building will be a bit of an oven or overheat. In our case, it's not going to be, because we don't have too much glass, and the glass that we have performs in a way that is very predictable, so we can ensure that the interior temperatures will be very comfortable year-round. Without good windows, adjusted to orientation of the sun on the building, looking at the heat loss, looking at the heat gain of the windows, you can't build a building and ensure its performance the way we're attempting to. Again, we're trying to make a building which will reduce the energy consumption by 90% from standard construction. Part of that is the insulation, part of that is the air sealing, and a really big part of that is great windows.